Hey everyone! In this video we are going to be solving an exact trig ratio from a given ratio. In the past we've solved trig ratios from a given point. This time we're going to be provided a trig ratio and we need to solve the other two. Here's a little trig ratio that we've been given, and we've been told that sine of theta is equal to 2/5. We know what the other two trig ratios are. We're going to need to solve cos of theta, and we're going to need to solve tan of theta. However, there is a small problem. It turns out there are two sets of answers for sine of theta equals 2/5. And this is determined using something called the cast rule. And I'm just going to quickly, with the horrible little lines, draw a grid here. And the cast rule goes like this. C-A-S-T. And these are the quadrants, and I can number the quadrants 1, 2, 3, and 4. Why are they numbered starting at 1 and going counterclockwise? Because that's the way that standard angles go. Yeah, we remember standard angles? What this cast means, C-A-S-T, is which quadrants, which trig ratios are positive. So in quadrant 1, the A stands for all. Sine, cos, and tan will all be positive in quadrant 1. In quadrant 2, only sine will be positive. Cos and tan will be negative. In quadrant 3, only tan will be positive. Both sine and cos will be negative. And in quadrant 4, only cos will be positive. Sine and tan will be negative. So in a question like this, where you're solving an exact trig ratio from a given ratio, the textbook or your instructor must give you a quadrant. In this case, let's say in quadrant 2. That's what we needed to know. We now know that we're going to be looking at some terminal arm that comes out in that direction. And we can kind of sketch what this is going to look like in a triangle. So I put a little triangle arm up, and we know that these thetas in exact trig ratios are always going to be the reference angle, so it's going to be right here, our little reference angle. If this is our reference angle, and we know that sine of theta is equal to our opposite over our hypotenuse, that's SOHCAHTOA, we look at the given ratio that we have, 2/5. Opposite over hypotenuse. Opposite, hypotenuse. We need to know this adjacent side. To get that, we're going to use just a little bit of Pythagorean theorem. So we can say a squared equals c squared minus b squared. A squared equals 5 squared minus 2 squared, and I believe that you can all solve this one fairly easily. We'll get a squared equals 21, and a equals the root of 21. Is this radical reducible? Does it contain a perfect square? It does not. So we can just leave this as root 21. I'm just going to give us a little bit of space here, and then we are going to finish this off. We now have all of the information that we need to get a final answer. Our cos of theta is always going to be equal to our adjacent over our hypotenuse. So our cos of theta will equal our now known adjacent side of root 21 over the hypotenuse 5. Double check now which quadrant we're in. We're in quadrant 2. Quadrant 2 says only sine is allowed to be positive, which means this cos answer must be negative. Box our answer. That looks fabulous. It is so beautiful. It is correct. Let's get our tan. Tan of theta is equal to the opposite over the adjacent. Tan of theta is going to equal our opposite side, 2 over our adjacent side, root 21. Can't leave radicals in the denominator. To get rid of a radical in the denominator, we multiply by the root of 21 over the root of 21. We're going to get a final answer of tan of theta equals 2 root 21 over 21. Double check our quadrant. We're in quadrant 2. Is the tan allowed to be positive in quadrant 2? It is not. Only sine is allowed to be positive, which means this answer also has to have a negative, and that is our second trig ratio. If you follow these steps, as long as you're given a trig ratio and the quadrant that it belongs to, you can get the other two trig ratios. Thank you very much for watching. I hope this was helpful. If you have any questions, please feel free to leave them in the comments below. See you next time.